NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we learn how to solve logarithmic equations of the form log base g of f equals log base h of f. Then we will solve a concrete example. Here is the key structure. We have log base g of f of x equals log base h of f of x. The core idea is that if two logarithms have the same argument, they will be equal exactly when their bases are equal and the domain conditions hold. There are two equivalent ways to write the conditions. System A focuses on g of x. It says g of x is positive, f of x is positive, g of x is not 1, and g of x equals h of x. System B focuses on h of x. It says h of x is positive, f of x is positive, h of x is not 1, and g of x equals h of x. You may choose either system. Pick whichever makes the inequalities simpler to solve. Now, a worked example. Solve log base x squared of x plus 2 equals log base 3x of x plus 2. We will use the system that focuses on h of x, which equals 3x, because that gives a simple inequality, 3x greater than 0. Write the conditions. First, the argument must be positive x plus 2 greater than 0. Next, the base 3x must be positive. That gives x greater than 0. The base cannot be 1, so 3x not equal to 1, or x not equal to 1/3. Finally, set the bases equal x squared equals 3x. Now solve the base equality. From x squared equals 3x we get x times x minus 3 equals 0, so x equals 0 or x equals 3. Apply the domain filters. X greater than 0 removes x equals 0, and x not equal to 1/3 is already satisfied by x equals 3. Therefore, the solution is x equals 3. Recap. Equal arguments lead us to equal bases. Always enforce the domain. Argument positive, base not equal to 1. Choose the system that makes those inequalities simpler. Here, the answer was x equals 3. Great work! Try crafting your own examples and decide which system makes the domain easiest to handle. We start with the equation. Log base x cubed plus x of x squared minus 4 equals log base 4x squared minus 6 of x squared minus 4. Our plan is the following. Enforce the domain conditions for logarithms, and then, as the algorithm specifies, set the two bases equal to one another because the arguments are the same. From the equality of the bases we write x cubed plus x equals 4x squared minus 6. Move all terms to the left. X cubed minus 4x squared plus x plus 6 equals 0. Following the grouping used in the solution, we split it as the quantity x cubed minus 5x squared plus 6x plus the quantity x squared minus 5x plus 6 equals 0. Now, factor each group. We get x times the quantity x squared minus 5x plus 6 plus the same quadratic. Factor the common quadratic completely. That yields the quantity x squared minus 5x plus 6 times x plus 1 equals 0. Finally, factor the quadratic. We obtain x minus 2 times x minus 3 times x plus 1 equals 0. Using the zero product property, we list the candidates. X equals -1, 2, or 3. Next, we must test these against the domain conditions we wrote earlier. The solution set is the set containing 3. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.